Hello and welcome. In today's video we'll be covering the basics of Perlin noise. And the thing you've seen in the video, we will gonna make it now. The waves, they are gonna be static or movable, or the mountain. Okay, so what is Perlin noise? It is actually an extremely powerful algorithm that is used often in procedural content generation. It is actually used in many games. I'm sure you've heard of it already, such as Minecraft and I don't know any others actually. The man who created he was called Ken Perlin, and he won an Academy Award for the original implementation. So what it does, a method itself, you pass it the number and it returns a value between 0 and 1, and based on that we're going to use those numbers and generate the terrain, the wave, or however you want to call it. Okay, so let's begin with, I will import my image that I downloaded. I will provide a link down in the description. Okay, what's going on? Okay, so it's here. Let's go ahead and create a material for that one actually. I'll just call it wave, and in the image wave. This package will be available on the asset store if you're too lazy to do it like this. So just go ahead and drag and drop that into Albio. So first we're gonna start off by changing our, let's go in hierarchy, create 3D object, hit plane, rotate it by the X, by the minus 90, and switch to 2D view. So we have it somewhat like this. Okay, so first of all, you can see it consists of triangles and dots and whatever not. This plane, it contains of 11 vertices on the horizon and the 11 vertices vertically. So basically that ends up with the 121 vertices, and we are going to be changing each and every one on the top, same with the bottom, but it will be degraded by 1 from this value, so we get the motion as it's a wave moving or something else. Okay, so first of all, what I'm going to do is I'm going to go ahead and apply that material. I'm just going to change the materials tiling. I think it's the -1 on the Y and -1 on the X, so it just looks natural like that. I got this image, I will probably link it somewhere from Shutterstock. Okay, so we're gonna call this wave plane. You can go ahead and create a prefab of it, we don't need it actually. And the next thing we're going to do is on the wave plane, a component, we are going to name this generate wave script. Again, this is as simple as it can be. I will not try to make it complex or anything. Got my tongue twisted there. Okay, let's go ahead and open up our script. Okay, so as I said, we're going to be defining the height and slopes of our waves. So we're gonna start off with two variables called height scale and detail scale. And yep, let's get into it. First of all, let's go ahead and delete this crap here. Make some space. Okay, so we're gonna go ahead and say public float height scale. Let's just assign its ballpark at around 5, and I want to make a slider in the inspector, so I'm gonna go these square brackets, range 0.1f, since I don't want it to be 0. I want waves, or at least some kind of waves, to max 20 floats. And I'm gonna go ahead and do the same for the detail scale, which is going to determine how detailed or sharp our wave will be. We're gonna go ahead and say range 0.1f, comma 40 floats, and it's going to be public float detail scale. I will say also ballpark it somewhere around 5. Now what we need to do is we need a variable to store our mesh, so we're going to say private mesh, and we're going to call it my mesh, and below that we want to store each and every of these vertices. These it's compiling. We want to be able to grab all these vertices, these dots, and to transform them into something and make them move or whatever you want to do with it. Hopefully you will learn a lot in this tutorial. And next thing we're going to do is say private vector3. Since it's in vector3, it's an array of vertices. We're going to call it vertices. Okay, so now we're going into the method that will be calculating all of that. And the first thing we're going to do is be saying void generate wave, like so. Okay, so since we have this, we're going to go ahead and start writing our code. First thing we're going to do is make some nice space in this method, and we're going to go ahead and say my mesh. We want to grab the component of mesh filter, and we want to grab the mesh from it. So we're going to go ahead and say equals this, the get component. I'll actually type it everything. I heard maybe in previous tutorials that was too fast. I'm gonna write everything slowly in this one. This is the get component, then the pointy arrows, mesh filter, parentheses and close them, actually brackets, dot mesh, it gives you an autofill. It returns the instantiated mesh assigned to the mesh filter. So we are going to be storing this thing into our my mesh variable, and we're gonna grab the vertices from here. So we're gonna go ahead and say vertices equals mesh dot vertices. Actually, it's a mesh with a I'm sorry, it's my mesh dot vertices, and close it here. Okay, so the next thing, since this is this one, we can all go through a for loop and just go through each and every one, but what I prefer is actually use a two-dimensional vector. We're not going to be storing this into two-dimensional vector, we're just going to be acting like it is a two-dimensional vector. So we're going to go a row and then the next one, then changing the next one, the next one, the next one, and we'll keep track of each and every row of its height, so we can lower the row below it to correspondingly have the y position from the vertices from its upper vertex. I don't know how to explain it, I'm sorry. So the next thing we're going to be is saying counter equals 0. We're going to go ahead and say integer of counter equals 0, z dot level. We can actually say int y level equals 0. So this is going to be a counter of rows, and this one is going to keep track of our rows, so we can level each and every one from the. This is going to act like I in the for loop, and this is going to be j in the for loop for a two-dimensional vector. So I'll just comment this is like I and this is like j, and I'm hopeful that you learned what a two-dimensional vectors are. In Croatian we call them matrica, but I don't know how to call it in your language, so we're gonna go ahead and say for int I equals 0. I is less than 11, since we said it has the 11 vertices. If you see, we can count them actually. It goes from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it will go from 0 to 10, which we have here. And we're going to go ahead and copy and paste this inside, but we're going to change the I with the J. So we're going to loop through these 21 times. And inside we're going to go ahead and say we want to call our future call calculation method, C-A-L-C-U-A, excuse me, how do you spell it? I can't. Method, it's kind of hard to talk and type for me. We're gonna go ahead and say counter, since this is something like J, or I mean I, and J is going to be for J, for Y level, excuse me, so we're gonna go ahead and say Y level, and here we are gonna increase our counter by ++, and in the outer for loop we're gonna go ahead and say level, Y level, ++. The next thing we want to do is actually we want to set the vertices to the mesh vertices, which we're going to be changing. So we're going to go ahead and say my mesh dot vertices equals to vertices. Since these are the vertices we grabbed from here, we're going to be changing that into calculation method. But I'm going to first finish up this method, generation wave. And so we are actually assigning the current vertices, the new vertices that we will be changing in the calculation method. I'm just going to comment in here and I will say changing vertices here and applying them later. Okay, so close it up. Next thing we want to do is say my mesh dot recalculate bounds my mesh dot recalculate normals, and this is going to create the colliders and everything for us, so we don't have to worry about it. Okay, so the next thing I realized that in new Unity you have to destroy the current mesh collider component and then the new one, so we're going to say destroy the game object the get component mesh collider and close it up, because it won't generate the new collider if we keep the old component. So we're just gonna go ahead and delete it, and then the new one, that is a garbage truck passing at 1 o'clock. I don't know why, I think. Okay, so the next thing we want to do is add the new mesh collider. So we're gonna go ahead and say mesh collider, since I want to store this mesh collider and change the mesh later on. We're gonna cast it and we're gonna say mesh collider equals game object, or you can say this, you don't have to say it, at component mesh collider, close it up, and we are gonna go ahead and below say collider dot shared mesh equals to null to clear it up, and collider dot shared mesh equals mesh, my mesh, excuse me. And this is it for this method. Excuse me, I'll go ahead and close my window real quick. Okay, I'm back, excuse me for this. Okay, so we're gonna go ahead and finish up our method called calculation method. So below there, okay, that's good, nice space. Below that, I'm going to be creating this method called calculation method, calculation method, and it is going to be taking a parameters of integer, which is I, integer of j. I'll just call them that way. And what we're doing here, we're going to say, actually we're gonna add an option to create waves or to be stationary. So we're gonna go ahead and say public bool waves equals to true. Actually we'll say equals to false, because I want them to be stationary at first. And here we're going to be saying if waves, Actually, let's go first if waves. What we want to do if the waves is false, we want to say vertices from I, so the current vertex, it will be beginning from here, it will be going from right to the left, right to the left, from the bottom, right to the left, right to the left, and we're gonna be seeing vertices from I dot Z equals, since we're moving the Z position of our axis, because this is the Z axis, so we're changing them to go up. If you were to rotate this like this, they would go here, rotated by 40, and yeah, okay. Value Z equals math.perlin noise, and it asks for a float of X and float of Y. Okay, so what we're going to be passing in is, open the brackets, we're going to be seeing vertices from I.x plus plus this transform dot position dot x. We don't need this. We just transform dot position dot x. Close them. Divide by detail scale. And say comma. I'm gonna go separate this into a few lines since it's going to be much more neater. Next thing we're gonna go ahead and say is vertices from I.y plus transform.position.y divided by detail scale, and we are going to be closing that here. Actually, it's closed, and we're going to be dividing all of this with height scale. Close it up, no errors, that's great. Okay, so if we're passing it the coordinates of the current vertice and the current x, and based on that it will return, I don't know, let's say 0.5. For this one it will return same or something different, but it will be close to this one, and it will appear that it is moving slightly up or down, which I will show you. So we're passing just the current values, and based on that it will generate the terrain, and it's going through each and every one, so it will look nice and wavy, and the whole plane will be messed up, but in a good way. So let's say else if waves is true, we can actually go ahead and copy and paste this. I usually don't recommend this, but we're gonna go ahead and do that. And if waves is true, we're just gonna go ahead and add one line above it. It's going to be time divided by waves speed, and I forgot to add that component, and we will add that to the the vertices x, and let's add it to the vertices y. That time times wave speed plus, so basically this will determine how fast our waves will be moving, and we will say float, public float wave speed. I will say 5, I think, I'm not quite sure, and that should be it. Let's go ahead into Unity. Let's see how much this is. Okay, 90 minutes. I think that is pretty much okay. So if I were to hit play, actually nothing will happen because I forgot to call this. We will call this in the void start method. First of all, let's say generate wave, and now we can go back into Unity, hit play once it's done compiling. Okay, so where is our... Okay, so excuse me for this one. I realized what the mistake was. I forgot to add it. So we forgot to actually... the mesh was here the whole time, but it all snapped together. I'm glad we actually had that error. So every vertice of this snapped to the first one. It created a wave, and we couldn't see our object because they were all in one line, which was unseenable. So we're gonna go ahead and say vertices I dot z equals, actually minus equals j, and we're gonna go ahead and do it for the same one, vertices from I to z equals minus equals j. And what we did, actually I made a mistake as well. We're going to be putting this exclamation point here, because if we don't have waves we want them to be normal, and if we do we want them to move. Next thing that remains is, actually, if you want, let's run it this way. We call the method in start generate wave. So when we hit play, it will generate the wave, which actually looks nice. But if I were to change this, nothing would have happened, or if I hit waves, also nothing happens. What I'm going to do is actually rename this into the update method, excuse me. And now it's going to be changing real time. So if I were actually to... Oh, and yeah, one more thing. This was positioned to 0, 0, 0. Since this one value and this one is going to be the same, you're going to get a mirrored image from here. I will show you actually. You see how we've got the mirrored image, and if we move, it will slightly move like that. So I'm gonna go ahead and move that to 0, so it's going to a plus. Command duplicate. I'm going to duplicate this a few times so it looks better. Okay, let's do it like this. If I were to hit play now, you see the waves are generated. And let's render it only once. And if I hit waves, you will see that they will start changing and moving, growing and getting smaller. And that's basically it. You can see we're moving the mesh. But let's say you want them to be stationary like waves, and you want them to be more detailed, smoother. You would use this one. You can see it gives you a nicer and smoother edge. And if you were to increase the height scale, you will get bigger waves, and if you were to scale down the detail scale, you will get sharper waves but more the edges. And once again, if we hit waves, it will be generating the waves. I'll just lower this down. This looks very nice actually. And if you increase your wave speed, it's actually going to be much smaller. So the smaller the value, the faster they will travel and generate. As you can see, one is pretty much 5 times faster than it was in 5. And that was it for today's video. Excuse me for some of my mistakes. I was doing this in real time with no pre-made stuff. And thank you for watching. Don't forget to comment, like, and subscribe. If you have any questions, feel free to message me, or even better, comment so everybody else can see your question. Till next time, see ya.